Alright, Tig Welding, Chapter 6. Alright, Haynes Welding Manual, Chapter 6, Tig Welding. When those interested in welding talk about fusion techniques, the subject of the TIG welding is held in certain reverence. The reputation with regard to the purpose and partially stemmed from its place in history of this method of the construction of the great many of the famous aircraft. Although developed in the initial 1920, the tungsten inert gas welding wasn't used in much because the helium shielding gas was too expensive. Instead, intensified research atmosphere of the World War II spurred the further development in aircraft, being the lighter of the lighter and lighter. The TIG became permanently method of joining such non-ferrous metals, aluminum, magnesium, such the Titanium Corporation, known as LTEC, of the first company of the capital of the technique after the war with the trademark of the name Heliarc became the de facto generic name of TIG welding. Many of the welders today still use the Heliarc more often than TIG as description of the type of the welding, even though the number of other companies have been making the TIG equipment for many years. Being side of the romantic, the TIG process of the considerable, quite special for the other reason it does with the considerable practice of the good, and it becomes these equipment always have the rather expensive, but the welder have the only ones good with the developing reputation, particularly with the esocentric materials and exotic construction aircraft with rare race cars because basically an outgrowth. Alright, 6-1 shows the TIG process conservative most process controllable the cleanest method of welding. The arc method between the work with the consensual tungsten and the electro rod torch weld. The flow of the shield gas comes from the nozzle. Note the low angle of the filler rod addition of the TIG, the hello arc, will also is one of the most observable welding process, no spatter little smoke. Alright, here's your TIG torch, electrical conductor, the tungsten electrical rod, the travel, the shield gas, the arc, the fill gas, the gas patch, the filler wire, the work, the molten welded metal, and solidified welded metal. Where TIG process is unequal as non-ferrous materials, other materials. Here are custom bicycle frames that are heavily arc welded. They're very tight and very thin walled chrome polytubing for the strength without welding penalty for the same reason the kind of material and welding process that used for the rail cars and aircrafts. Where the welds in aluminum have to be the pretty with the strong with the TIG. Again, top of the choice, the welds. These two machined with the polished parts with the easily wired brush looked as good as the polished parts. 64. Unlike arc welding, MIG welding, a welder can get in even closer to the work with the heli-arc equipment, even when the welding with a cast aluminum, dry sump, oil pan, smoke, minimum arc, not necessary intense. Arc welding TIG process is done with a lightweight torch with the using tungsten electrical eye draw. The intent of the concentrated arc shield with the inert gas. The gas comes out of the torch around all around the electrode display with the welding air with the welding zone with the excess oxygen and nitrogen with the contamination weld. Although the helium was the original gas used today, argon is most to shield the gas with the TIG and the welding tungsten electrode is not considered the consumable usable sense, since filler metal is supplied by separate handheld rods with much of the like oscillation welding. In many ways, the helical arc welding, like the highest high TIG version of old-fashioned gas torch, the concentrated in nature of the TIG, and this arc is one of the most strongest points welded and getting great strength with the quality of made for the in the end metal, the little material similar materials. In fact, most of the available metal with all the minimal distortion, corruption, and the joining of the base metal with the process does not generate sparks or spatter with the wider welds are clean and clean as can be. Which was why the method of choice for the aircraft, race car construction, stainless aluminum products made of the medical, dental, food handling services. There's no slagging involved because there is very little smoke generated. The welder has good view of the process, allowing him to make the very precise joints. The welder has a greater control with the TIG than most of the other welding methods. Of the amperage is controlled infinite because they become size. The setting with the power source. The welder has a foot control of the operates as weld. We recently asked a veteran welder to make some samples over the TIG welds photographed for this book. There was to be one beat several bad ones. Even when it was set with the amperage very in one way too high and one way too low, and he instinctively tried to produce a good beat, adjusting the torch speed and foot control compensation. He could not make himself do a bad weld, and once the arcs were started, he tried his best to made a fairly good weld, even with the machine parameters way off. 5-6. The precision welding involved, especially in tight quarters such as the stainless steel race car headers, the TIG welding wide range of the operator controls is seen as the option as an advantage. While the good torch manipulation TIG welder can weld thin metals and thick ones in stainless steel and steel to cast iron and enough other oddball situation, the good with TIG welder begins with regard to some of the magician. Some is a magician. In the time when they were their friends that had fabrication shop that did protection job, heavily arc welding some of the aluminum brackets, some of the prototype motorcycle seat frames that is required for the Lamborghini aluminum wire pump casting, welding up with the fancy the cast aluminum mailbox poster with the head run over the and finally gunshot and smooth brought the trigger barrel with an anti-cavalry carbine to repaired with a TIG welding. How he had handled them all equally a plum. It was obvious that the people around him brought tough jobs to him, knowing that he could handle it. Alright, 6.6. The thick wall of the mild steel tubing with the race car chassis welding usually done with the mega equipment to recover the speed. However, the chassis lightweight thin wall 40-130 of the chromo moly tubing was TIG welded. There were a lot of man hours to represent here with the precise fitting joint for welding time. 6.7. The most shop of the type of TIG welders heavily bolt power source with the required three-phase input power of the water connection, making them less portable than other welding machines. This is Miller's single wave 250 popular unit with many fabrication race car shops. Alright, we've discussed mainly the type of the welding system with the point with each of the design with its disadvantage with the TIG welding. There are only few disadvantages. The very few TIG welders can't do it, but there are some jobs that other techniques that are better suited for the practical reason, not because of the different quality of the strength of the weld, but for the bigger jobs of welding up a car trailer or the big metal racks being made with the steel tube and the heli arc just tool arc welding with a mega that would be much faster. However, the application for the aircraft with the race car chassis work with a large problem maybe tedious, done with a heli arc, some because of the lightweight with high strength material, thin wall 4130 chrome moly tubing. The tube with the TIG would be preferred method for outdoors work. Again, arc welder and flux core MIG welding are the best choices because they are not affected by their air currents. The cost complexity of the TIG system has kept in the hands of most of the small shops until the last few years. Most of the TIG setups are heavier than small, the weight of 800 pounds have to move the crane with the hydraulic pallet. Most professional units with the water-cooled torch assembly which involves 10 of some plumbing connection shop that beside the normal electrical hookups. Some big shops, the type of the TIG machines have always been about the most expensive welding machines available, which has increased their mystique not widening their market. In the last few years, there have been manufacturers that have built the smaller, lighter, solid-state electronic TIG machines to make them more attractive than small fabrication shops, race car shops, street rod builders. Many of these machines are now air-cooled, and at about one-third of the cost of the traditional TIG machines, they are also been being seen out of the field more as one street rod builder told us. There's one thing on the car that would require me to have a 600 amp welder. When you design the builder brackets at the time, the torch never gets to that hot. The main difference between the uses of large industrial TIG welding machines is the economic TIG is only a market today. The big boys can be weld all day long and any amperage they need, never overheat the torch or electronics. They are air-cooled smaller TIGs that are fine anything but seams in welding big aluminum castings. 6.8. The basic TIG torch is very light and easily to hold, comfortable, quite durable, and only consumable with the filler rods is used to some extent in the tungsten. From the exploded review of the TIG, the torch showed the tungsten right at the top of the bottom of the back cap of the cullet shock, the torch by the ceramic cup nozzle, and the assembly with the cullet chuck, the screw with the torch body in the bottom of the nozzle, screwed in the bottom into the collector side of the top, and the tungsten and slide in and retained back cap. Alright, the equipment. The basic equipment of the TIG setup includes the power supply foot with the control of the water circulation system of the torch. The ladder differs from the other type of electrical wire welding torches, but being smaller and lighter, holding the central rod and the tungsten as an electrode for the arc. Taking the torch apart with the ceramic shield of the business end of the cullet, the ceramic, the gas cup with the nozzle, the cullet which remains the tungsten with the cullet body and the back cup. The customization of the torch, depending on the work to be done, there is different sizes of tungsten, different gases of the cup, the shapes with the specific kind of the job, different back cup, the length, depending on how tight the quarters are, or when they weld has been made. For instance, so that you can see the short tungsten short back up the cup to fill the tight with the tight corner better. The shape of the gas cup, the crater with the different shape of the side of the enveloping the shield gas over the welded area. The large welding machine company, the various different types of torches, bodied with different amperage capacity that was welded model with special models made for the tight confinements, including one of the tungsten and ceramic nozzle that comes straight over the handle rather than in an angle that most of the TIG make torches. When it comes to basic power supply, you will find a need for the range choice, but the set of the MIG welder part marketplace for the TIG equipment is still pretty much the professional or the newest and expensive. The air-cooled TIGs are at one end of the big shop unit, at the other the few choice they make. The TIG setup is not a home-style type of welding process, but there are certain specialty fabrication businesses run out of the home, the garage that could be used the TIG machine, particularly with the world work involved with aluminum, stainless steel, non-fierce metal parts. High-quality, squeaky clean welds are important to protect strength and appearance. If you have had a small business making stainless steel rope clips, there are other items, rock climbers, for instance, that you may weigh the cost in an air-cooled TIG versus sending all the parts out to be welded in a shop. If you had a volume of the work to justify one-time cost to learn how to process if it could be a good move to do however it could be wise to make some TIG classes to get yourself certified first. Alright, 610, there are only a few small portable TIG units like this one, 100 amp pulse TIG with a Daytona MIG 220 volt DC only machine, said to be suitable for steel, stainless steel, and chromium moly up to 3/16 of an inch. Also, the 6 and 11 mid-sided TIG machine are able to 160 and 250 amp, ranging from fairly portable to make Daytona MIG unit, the 130 amp, 220 volt mid-range machine. Their options are like slope control, positive flow. One has the square wave technology ACD operation. Input of the voltage the TIG machine begins with 220 volt range, single phase power with the professional box. They are 460 volt, 3-phase. The professional unit with the range for the amperage capacity of 250 amps to 300 to 400, 500, 650 amps. With large one, but the multi-technical machines in which for the high amperage probably with the arc welding, it would be pretty rate to use more than 300 amps for the TIG welding unless they have more would weld really thick aluminum plates or casting. When welding about 300 amps or more tiny, the tungsten arcs can become included in the weld, which will weaken the joint in 3-phase of the current mode. The definition for the shop used to make the mount of the shop of the equipment. The power used every month makes it expensive for the transformer, rewiring, building economical over the long-running utility bills. Home shops generally do not have 3-phase power. On the small shop scale, there are varied TIG capability units with the 150 volt range, on which this have been seen with the Hobrat Ultra Weld, the 130, which is an arc welder with the TIG capability, with the limited range for their either 115 version or offers a 75 amp capacity of 40% duty cycle to 220 volt. The model offers 130 amps at 60% duty cycle. It does not include the TIG Torch or the TIG ranging material thickness of the wood be limited. We expect that its home TIG market expands. There may be some interesting and smaller 125 volt, 220 volt units to come. A few imported TIG units are built with the DC only compatible to seek the price down to the starter level. They are fine or steel only with up to 3/16 of an inch. You see illustration. Of the medium range TIGs, there are several domestic and improved brands offered with the 120, 60 to 250 amp category. They handle virtually anything in the small shop environment. Most of these 220 volt or more input current requirements, but most are single phase, which means you can easily wire your shop to accommodate them. But be advised though that even the 160 amps until you draw 336 amps out of the input power at the highest setting, and 250 amps can be drawn to 60 amps of the better full load. This means for the household 30 amps to 220 volt circuit would blow at any one of the higher settings, which would really need a separate circuit with the box of the welder with a 50 amp breaker for small rigid machines, a 100 amp breaker for the bigger ones. Or 612, when you go up the welding machine side, you get the amperage for the higher duties on the cycle. The TIG Star 250 operates on several single-phase input currents, has a 60% duty cycle at 200 amps and a 100 duty cycle at 140 amps. Alright, your AC sinew throttle lines, amperage and negative, and then your AC square wave, the positive, negative, positive. Standard sinusoidal wave, the AC current with constantly reversing polarity output is always fluctuating in the wave flows. The new square wave technology electrodes uses higher currents of wave with a good arc starting stability, but with the radio interfering with the traditional high frequency superimposition. The square wave design interverts with the current much faster for the better worlds on the non-ferrous metals. The mid-range machines offer several specific features such as slope control that refers to how the wave of the current cylinder, when the machine is welding, picture the wave of the curved line that goes up and down, crosses the baseline, then curves back over the repeated fashion many times a second. This is called the sinusoidal wave and an alternative current. The TIG machine uses the AC and BC current. As the AC uses the non-ferrous metal like aluminum, magnesium. On one half of the AC actually straight polarity, and the other half the reverse polarity. The straight polarity position portion of the wave building the heat of the arc, while the reverse current has an effect of the cleaning of the oxides and aluminum being welded. So the TIG torch for the AC is constantly cycling between hot arc and clean cycle, but at the lower amperage of the arc can be obstructed by changing over the point of actually going out. Most of the TIG machines have special circuit inside of the product produce highly frequent low power extra current that keeps the process going all the time. The high frequency control makes the TIG arc easy to start without touching the tungsten to the work, makes some more stable air arc while welding on one of the machines with a high frequency system can be set on the front panel of the welder arcing setting, starting off the continuous use of the non-ferrous metals. Ferrous metal welding high frequency is used mainly for the arc starting. The slope of the control feature with the welder can adjust the parameters of the wave on the top of the U with the inside with the perfect combination penetration cleaning action of alumina. Even the clean piece of aluminum contains aluminum oxide as the base material. Slope adjustment allows a good weld to be made with these oxides being included with the bead. Most of the today's TIG machines offer the square wave AC with the traditional sinusoidal wave high frequency that creates a lot of radio interference as well as some of the problems of welding aluminum. The new machines are solid-state electronic features that make the wave made up of down squares rather than half circles. This means that the high-frequency control intervenes with less often than same-size electrode can be used with a higher current. The discussion of the current waves may be more than home shop the user needs to know, but at least you may be better understanding the language using the manufacturer described equipment, since it says that the modern square wave technology and the solid-state electronics are desirable features on the full TIG machines. Another feature you may mention the positive flow, where you're making the bead to get in the end of your seam. It's a good idea to allow the gas to flow over the end of the weld as it cools to keep out the contaminants. On the professional machine, there is an adjustable timer that allows the gas to flow so many seconds after you have stepped off the foot control to quit the arc. You keep the torch placed in where you have stopped, and gas keeps flowing in further specified. This is helpful on steel, but is essential with aluminum, magnesium, brittle, and high-strength steels like the 4130 used in the aircraft, the race car construction. It's called post-flow because of the post-welding gas flow. The post-flow of the water gas taking the torch also helps to cool the tungsten electrode down to the point where it cannot oxidize the regular shop air flows there after the welding stops. 614 shows the less expensive air-cooled torch TIG machine that had been available to no more than some time of making the inroads into the shop. The TIG was previously considerably expensive. This is the Miller Econo TIG. Is being used with the street rod shop on home-built cart to make the portable using machine. 615, today's state-of-the-art TIG machines are represented with the 300 amp LE Arc 306, the LT. You see the new name of the Lindy Corporation, the original trademark holder for the name of the Heli Arc. All solid state in the square wave technology provides high performance, high reliability bells and whistles, including the slope of the control, spot welds control, wave balance and control, and post flow and arc force fine tuning adjustment. Most of the shop of the TIG machines feature the water-cooled torch, but some of them are cooled with the water cooling system. That is an option, but see the illustration above. Obviously, the extra equipment that for the water-cooled torches add the total price for the package. Some of the shop of the water cooling system consists of the only unit and they add the basic power of the supply, containing 1.5 gallons of water. The water circulating pump is a small radiator fan with a mixture of miniature automotive cooling system in the shop where the amperage can be quite high, where the long welds are made. The torch may be hooked with the source of the regular coal to hot water, heated return water to flow to the exit of the shop and drain with the system with the use of the wet water, and both keep the torch cooler than the recirculated water system. See illustration. Shield gas system of the TIG welding system isn't much different from the MIG welding as discussed in the last chapter, except that you use helium, argon, and mixture of the two in your bottle. Most of the TIG setup with the large bottle, and possibly because of the portability is usually concerned with the TIG welding. See the illustration shops that do the TIG welding usually have the machine set up right near the welding table to not move them around, although the newer air-cooled units that can be wheeled around in the shop without too much trouble. Unlike oxyacetylene bottles, most of the MIG welding gas bottles use 2-gauge regulators The TIG setups have a single round face gauge on their tanks, a flow meter instead of the other gauges for the line of flow. The flow meter has a vertical glass tube with a numbered increments measured marked on a color ball inside. The argon bottles are available to number the size depending on whether you are trying to make the TIG setup the portable or not, and how much welding time you need. And shown here from the left, the side are 20 to 55, 80, and 125, 154, and 248 cubic feet. When the gas is turned on and click your foot on control on, the ball will float up inside of the tube with the indicating level of the gas flow into the cubic feet of the gas per hour. See the illustration. Professional welders like the flow-o-meter better than the gauge because of the colored ball that can be seen with the floating of the tube as far as away as the welding table. They do not have to get up and go look at the face of the gauge and go gauge on the tank. They can just step on the pedal and pedal to start the gas flow. See the flow meter as set to the right, and then they can also tell you the forgotten to turn on the gas bottle before starting. Our 617 is flow meters of argon bottle with a TIG used in the general use place for the 2-in gauge setup. Instead, the glass tube is on top of the colored ball and floats along the metric scale to indicate the gas flow without required welder to step down away from his work. Alright, the argon is versatility enough to be used in shield gas almost to TIG work, simplifying the storage of the bottles. Often a large bottle mounted on the welding cart is often needed in some smaller shops. The correct gas flow is important for the maintaining the integrity of the weld to keeping them out of containment. For the basic steel with a flow rate of 8 to 10 cubic feet per hour, argon is sufficient up to 1/8 of an inch material, but if the gas flow's requirements go above the amperage with the thickness of the metal beginning with welded. Stainless steel requires only a little bit more gas flow than the plain steel, but if you were welding aluminum, the gas flow recommendation would go up to 100 from 20 to 15 to 20 cubic feet an hour. The same thickness for large diameter tungsten may be required. Argon is certainly basically all around shield and gaff to take profit today that is usable on virtually all metals. Straight aluminum and seldom used. Often the production work of the mixture argon helium is used to get the best properties in both gases. Argon has the quality good of arc starting, cleaning action for the best pedal control, while helium makes the hotter welder greater penetration and faster welding speed, such as when welding the thicker material. The argon helium mix is often used all allowing welding for the non-ferrous metals at high speed, and the helium in the mix helps more heat for the aluminum welding is in a way that one welder described it as like adding a turbocharger. Alright, the processor in action. Basically, TIG welding is enough like oxosilicate wedging that have already learned well how to weld the gas with a gas torch and learn how to curve with her TIG welding how much shorter than from most often welders who have never learned. Or 619 feet, a comfortable position of the torch in hand is more than half of the battle, achieving the same if the TIG welding player practicing making the beat of the proposed setup without turning on the arc. Just to find a comfortable position, note that the low angle and position of the filler rod of the welder's left hand. The 620, the TIG welder, and some of the years back, today on current crop, the TIGs are half the size of the water cooling unit here of the mounted on top. They add the left, the rack, the metal tubing holding the various welding rods in the foot pedal. The amperage control is in front. 621, layout of the front panel, typically of the most TIG power sources with the controls, of course, with the fine amperage current type and the 5 frequency and post timing. With the torch, it can be easily challenging as it is rewarding like gas welding, and the operator must use both hands, one for the torch, one for the filler rod, each for the wood, which must be moved along with the welding seam at the same time. Steady rate. See the illustration. In addition, with the TIG welder, with this operated with the foot pedal, the control the amperage device, use the clamp directly to the torch body with the remote, the welding machine. See the illustration. Use the remote control to use the operator with the privileges. The TIG process, allowing the welder to start the arc and infinitely verify the welding currently as he is welding any of the arc without moving the torch, being able to vary the amperage while making the weld, which makes the TIG welding so versatile that it handle the different thickness for the melting metals that joints. This similarity materials just as the right amount of heat can be aimed at each side of the joint, and this also helps to make TIG technique that can work with all position welding too. TIG machines produce an AC output of the high frequency over the HFAC or DC. The high frequencies are stating only the C illustration. Most TIG machines have a control front panel switches between them and the types of current over the control of select the basic amperage range control of the high frequency and post flow. See illustration. 623. The three position switch, the left, the high, the frequency, the right, the post flow timing related with the various types of tungsten. Bigger than tungsten, the more post flow time is to cool off. 623 left lever left of the Miller Tig setup with the polarity, while the right level is course the amperage of the bottom setting of 10 to 55 amp, the medium range of 40 to 190 amp, the top range of 220 to 310 amps, which each range with defined amperage knob settle up at the upper limit of the pedal. The AC U with the non-ferrous metal with the U with the only with the high frequency during the welding, except with the new square wave machines that don't require the high frequency all the time. The DC current can be either a straight polarity or reverse polarity. The straight polarity or the DC straight polarity is U with the stainless steel with the silver silicone copper, the base alloy with cast iron dioxide copper, the titanium with the AC main for the aluminum magnesium. Set your machine to the direct current straight polarity. Sometimes the DC high frequency start only in position setting of the amperage of the material. They have working with experienced TIG welders use instead of a three-position amperage levers as the coarse adjustment the dial from the fine amperage of the control with the knob. The often welders will set a fine control all the way up and all the way up using the pedal as an ultimate control. The way that during the welding, welder needs a little bit more heat, he just pulls on, puts the pedal down further, and whatever the sets on the limit of fine amperage knob, that's much as you can get from the pedal. See the illustration. There should be a chart with the machine that tells you the correct size of the tungsten electrode to use the various amperage for the material thickness. You probably use the 1/16, 3/32, 1/8 inch. Almost everything you do, there are two basic kinds of tungsten material: pure tungsten and telluride tungsten. And through the pure tungsten works and under conditional and all the materials, but is required for the AC TIG, while tellurated tungsten is the direct current straight polarity welding are used often because they may make slightly better start and penetration. 624. The pedal with the fine welding control of the amperage of the TIG welding until you are experienced. You may want to see the amperage knob at the highest you need for a particular job. You know that when you are welding, the pedal can go all the way, and it takes some of the experience to know how much pedal to give, and if the knob is set for the max, the amperage range for the coarse adjustment. Alright, tungsten are somewhat expensive, but can be made for the last a long time. So the sharper the improvement for the good arc starting, the penetration steel with the TIG welders keep the small supply of the sharpened electrodes handy and slip with the torch. Most welders won't well sharpen both ends of the tungsten, so that if they need the new point right away, they just loosen them and back onto the torch cup, back onto the torch. Slide the tungsten out of it and reinsert the new point down. Good welders can do this in a blink of the eye. Belt sander grinder is usually used to sharpen the tungsten, but it should be dedicated sharpened source. The grinder should use the smooth steels and aluminum will have the deposit so that it can contaminate the tungsten. It can't contaminate the tungsten sharp tip of the light sharpening a pencil. Only the grinding length of the wires with the electronic grinding from the tip of the back of the main grinding and held sideways. The grinder will leave the pattern and marks on the tip that may contribute to the arc scattering. The electrode tip of the used aluminum HF's AC shall be sharpened to the clean but much duller point to use the steel. See the illustration. Theoretically should be separate with a certain ceramic cups of aluminum work, but many of the welders may use the same cup of the both steel and aluminum TIG welding. When tightening the electrode for the torch, push the hole of the torch straight down against the solid surface with the welder off to see if the tungsten will slide in. If it slides in, the tungsten wasn't tightened enough. See the illustration. Our 625 most expensive tungsten electrode, using them until they have too short to fit the torch. Short of tungsten can be sharply sharpened without burning your fingers using a tungsten holder like this. 626 spare sharpened tungsten should be kept handy with the TIG caddy, which holds the extra tungstens as well as the spares for all the torch parts. The different size collets and nozzles. The caddy is magnetic and featured with the covenant touch reset. At the same point, your tungsten will contact the puddle, but this is desired, but it happens to everyone. But the pedal will be back all the way with break the arc, and keeping the tungsten is glass flow over the few seconds until it cools off with the later. They continue to weld the tungsten after the torch is either filled the rod and puddle because of it. Alright, 625. It is important to sharpen the tungsten lengthwise tip so that it is not leaving any radial grinding marks that could cause the arc to scatter. Grind points are steel with like a pencil, like a crayon with welding aluminum. Alright, 628. The tungsten at the bottom that has been sharpened and used with the steel below the top of the one, even the one is for aluminum with a small ball shape. And in the end, the theory that you could create a ball end like this to striking an arc on one piece of the copper for using the tungsten aluminum by a suitable dual point will turn into the ball like in a few seconds using the Havoc for aluminum. HF's AC for the aluminum. Alright, 629. The sharpened tungsten is inserted into the torch body where the tip is sticking out of the right distance, and you tighten your back cap to hold it in place. Alright, 630. Although you crank up the gas flow to the extent of the tungsten tip of the further and reaching it at the side of the corner of the normal extent for the tip, it's 1/8 of an inch, 3/16 of an inch for the tonsil. Oh, you can make a lot of practice beads with learning the Tig, but you have left. Here are left the way we have. A, the bead is too low and amperage and bead sits up proud. B, the current control seam is about right. C, the amperage is set too low even through the bead seam okay on top. D, way too hot and with the bead too low, too wide and sunken. Alright, 6-3. The backside of the weld, same plate with the previous weld. Note that the A has been only in slightly discoloration. B is closely being the right and with a tiny bit with the drop through. And C is too hot and with lots of the drop through, while D is not hot there, more bead underneath and on the top. Be contaminated with the arc that won't be clean with the stab with the back and with the pit section of the tungsten will have to be broken off with the hair applied with the tip of the will need to be resharpened. Although the tungstens are not considered the consumable numeral sense of the welding term, but they do get shorter every time you break them off the piece and every time you resharpen them. So eventually they become sharp through the use. When welding in the tight corner of the sharp back of the cap is used to stubby the tungsten, but otherwise use the long cap to protect them from the contact with the other sharpening tips. When you have sharpened both ends sticking out of the tungsten, the how long back of the cup covered over the full length of the new tungsten. Turn your gas and sea flow back to 10 cubic feet an hour. The attack of the work leave with the sample plate run with the simple practice bead. The tungsten should be held to the torch side. That 1/8 and 3/16 of the tungsten stand out past the ceramic coat. At no time should the tungsten touch for the work. When you bring the electrode to within 1/8 of an inch for the work, the hip, the foot pedal, the arc should start. There will be a red-orange glow at the tip of the tungsten as you move the tip of the round, the small circle in one spot from the torch, perpendicular at the work to the work. Bring the pedal control down with more amperage. When the puddle is in bright fluid, move the torch along with your seam slowly, evenly. The torch should be now be tilted back to 75-degree angle with the rest of the bead. To stop the process for any reason, just back off the foot control all the way to break the arc and keep the torch open the same spot to the cool weld and tungsten with the gas flow. When adding the filler rod as most of the joints any thickness for the other than thin sheet metal with the move of the electrode rear of the puddle of the dip of the filler rod to the flower forward edge of the puddle, bring the torch to the front again to make up the new puddle, move back, add filler, move again. This may sound like too much of the work, but really is very similar to the gas torch welding and the movements because of the instinctive after enough practice. The filler rod should not touch the electrode and should kept near the forward edge of the seam to keep it not between dips. When it's brought to the molten lead and leading edge of the puddle, the drop molten seal will come off over the rod. Puddle will be blended when the torch advances it. The filler rod is used to align with the direction of the weld travel to held down the shallow angle of the work. The rate at which you travel depends on the thickness of the material you're working with, the amperage, desired height, and the width of the bead. They are too cold, the amperage to travel too fast. The bead will tend to stand up more, even if it looks smooth and uniform. Their weld wouldn't pass the bend test because of the lack of penetration. See illustration. If you are too hot, moving too slowly, bead will settle within the parent metal, leave the long carrier at least on some of the undercutting on the either side on the metals thicker than 1/8 of an inch thick. The edge should be beveled. Will be probably makes more than one pass. The bottom pass, the root pass, the ties of the piece together. The subsequent passes can be made with a higher amperage. Tig welding is not processed with quickly filled with a large gap. The bevel sealed on the thick plates. Making the arc welding is better for that. The filler rods are used for the Tig welding may look exactly like those for the gas welding, where they aren't. The Tig rods are steel welding and they have deoxidized added. For the fact that one brand called the AAA deoxide, if they accidentally use the gas welding rod, they can make the bead butt and the weld with exhibited prosperity. The proper Tig rods are very helpful with welding quality steel, which may be their hot rolled steel you'll find in salvage pile at your local metal steel supply. There are a variety of filler rods, including special bends using a low alloy, high strength sheet metals now used in automobiles. After welding your tungsten rod, you should be silvery, relatively clean. If they show the signs of contamination or rough too much, they usually indicate that the air leaking is somewhere within the torch, the shield gas leaking out, somewhere to check the able to fill out the cowlet and ceramic cup. If the electrode hits as a ball at the end of the miniature flagpole, then the amperage may be too high for the diameter of the electrode. The tungsten should have the ball on the end of the bigger than 1.5 times the diameter of the electrode itself. If the tungsten tip is black or blue, then check the timing of the pass flow of your machine. If the tip is the black, it means the tungsten is cooling off the atmosphere, and instead of shielding gas, you need a little more of the post-flowing setting. All right, looking at the inside of your ceramic cup after the welding, check with the contamination. A cup is too small for the work will show the deterioration. Even the cracking cups are usually size of 1/16 of an inch increments. A number 4 nozzle is 4/16 of an inch or 1/4 inch, or number 8 is 1/2 an inch. General rule is the size of the cup is measured 4 to 6 times the size of the electrode being used. Your practice time before obtaining the suitable bead will vary with your skill with the previous welding experience. We have established the similarity between TIG welding and oxytilate gas welding such that you can pick up the TIG welding in much faster than already with the accomplished gas welder. When you have practiced straight beads and flat welds, have those down fairly well. Then try some of the corner T welds and the vertical seams when they are completely comfortable with the more difficult welds. And the piece you have done with the past simply with the bending test and cutaway for the examine and penetration, you may be ready to do some actual project for the TIG welder, but do not start with the right away for something critical like an automotive suspension or steering part, anything that goes on an airplane. Alright, TIG Welding Aluminum. Perhaps a little more difficult to learn with the welding steel precision joined with aluminum magnesium are among the pressure primary reasons that have TIG welders, so that they should be your next area of practice. You need well-lit area to do TIG welding because their arc is not as bright as the other electrical techniques. On the aluminum, you really need to show how the pedals are developing. Set your machine to the HFAC, which is high frequency continuous unusing square wave feature. That if you have it, and adjust the post flow with the 1/8 of an inch electrode, you can clean 1/8 of an inch electrode pure tungsten with a tip shape of aluminum with a needle sharp point. Adjusting the flow meter for the argon to 17 to 20 cubic feet per hour with a set of 1/8 of an inch thick aluminum plate has been thoroughly down on the welding table. Aluminum tends with the age to harden. When exposed to air, the aluminum oxide will constantly build up on the surface. Such the oxides are not always visible. Parts to be welded need to be cleaned just before the welding to provide the free surface. Do not use the chemical cleaners for preparing aluminum unless it is something you have purchased. Litigating the legitimate welding supply store household automotive cleaners may contain chemicals that will vaporize during the welding, create toxic fumes. Use stainless steel wire brush, but not steel wool only. Whenever use the stainless steel brush for clean plain steel. Since most of the sandpapers are made with aluminum oxide, this is exactly the material we are trying to eliminate from cleaning the aluminum for the helical arc welding. Do not use the ordinary sandpaper to pre-clean. Use an aluminum welding rod. Clean the welding rod before starting using alcohol lint-free cloth to wipe them down. The aluminum part you are welding should be grounded to your table. Lightweight plate and put your heavy weight on the part to keep it in contact with the ground of the table. Attach the work clamp directly to the part. Otherwise, you may find the bottom of the aluminum part that you have welded on the table that it will have arc burns for the intermediate contact with the table. Draw the bead with aluminum from the short distance and immediately cut off the arc. Examine the weld, and you may probably see that you have stopped there with a small depression at the end of the bead. To avoid this at the end of the weld, do not back off suddenly, but rather ease out of the weld while slowly moving the tip back over the end of the puddle, but it should keep it from sinking. Try to maintain a puddle molten amount of about 3/8 of an inch wide, going to the fast keep it with an air or the vice versa. You will want to see any really change with the aluminum when the way that you use the seeing the seal altering during the welding. The only include the area of the become molten is get a very shine in that spot. You will have to work on the change of the reflectors will make in the series of pulp to make up the bead with because the aluminum metals 1250 degrees Fahrenheit. Most of the lower than steel can overheat it easily intensity with the arc. When the welding is you have the whole range of the colors from which the metal turns in the different temperatures. The color makes it easier to tell what you have the metal molten when it just started cooling off, and you won't have the advantage with an aluminum. You will probably burn through a number of samples before you can learn the temperature control for this metal seal illustration. Alright, when you're learning TIG welding in aluminum, keep your torch angled so that you get a good close and look at how the puddle develops in molten areas. Because with the shining, you need enough heat to form the puddle, but not much more than aluminum vaporizes. After the weld is completed and cooled, you'll see your bead is nice and shining because the material has been melted and looks as good as virgin aluminum, just as out of the foundry. But along the outside of the bead, you'll see a light-colored band with a contrasting jewelry. At this end of the area, the aluminum oxide have been vaporized from the welded bead. High frequency in the arc deposit the next welded aluminum plate have been practicing on the was not entirely clean. You may See some of the back of the lots black smoke residue with a wide dull air with either the side of the welded bead indicating that too much aluminum oxide was present. Inspecting your welds, use uniformity, appearance with cleanliness, and check the back side of your weld for evidence of sufficient penetration. Alright, 634. When welding a thick aluminum material, aluminum casting on the fancy mailboxes, post edge must be thoroughly cleaned and available before welding. Alright, 635. The rosebud tip of the oxide silicone shorts the either method of preheating the thick of the cast aluminum before the heli arc metal welding. In order to not warp the cast iron aluminum heads, the manifolds and blocks, use the heat markers on the metal while heat preheating. Alright, when TIG welding any aluminum thicker than 1/8 of an inch, desire to preheat the aluminum to 350 degrees before welding. This is also particularly important with welding aluminum casting, such as preparing cylinder's head, water pump, the aluminum engine blocks, bell housing, and other automotive part castings. If the casting isn't preheated before welding, the probability of the crack again later on due to the welding section may expand more than adjacent metal, then shrinking. An aluminum casting soaking up a lot of heat. The initial welding is made easier than the part of the preheated because the parts doesn't draw off the heat while you're putting them back in the seam of the melt. Preheating the automotive casting also helps to bake out any of the dirt and oil that may be present with it. Although aluminum casting should be thoroughly cleaned before they even attempting to weld. Even starting with a clean casting of the bead out crack, the impurity of the casting may keep the coming out while the weld. Ideally, the aluminum parts should be evenly heated in temperature-controlled oven, but some parts of them won't fit in the regular oven. Perhaps the boss of the kitchen may not allow it anyway. The alternative to use the temperature-sensitive paint sticks with a welding supply. Use one of them made for 350 degrees dab, swabbing the various parts of the casting. Heat the whole part of the rosebud tip on the oxysilane torch to adjust all the temperatures indicated to have melted. See illustration. TIG welding stainless steel should prove to be very similar with the practice of the metal steel that makes the stainless steel different from the ordinary steel content with both chromium nickel part with the part of the region or the might higher expanses. You will find some of the characteristics that are different, such as the heating staying in the bead area longer than the implant with the steel bang because the stainless steel is only half about the conductor of the heat of the regular steel, and once the stainless steel does not take the heat, it expands some of the 50% more of the mild steel, which can cover the problem of warpage and thinner materials and beads are clamped and jigged and securely during the welding process. The critical welding and adjusting industrial jigs may be made, but the copper may cover the conductor to help carry the heat out of the stainless steel part quicker. Or 634, the welder Bill McGuire, the TIG welding heated mailbox post using the rotating welding steel stand he invented. At the bottom, he has a round disc that you can spin with your foot, leaving that your hands are free to continue weld, especially where you have gone around something. When you have to go around something, this should be available sale at the time of printing. Alright, at the time of set up the stainless steel, it can be TIG welded with the argon flow set only slightly more than steel, the 11 to 13 cubic feet per hour. Or 637, no one knows better what the welder would know than a welder. Any other inventor with the Bill McGuire's is the pocket feeder. It is the patent for the sale made through a major supplier. It hand feeds a welding wire from 20,000 of an inch to 3/32 of an inch in your weld while handling your while your hands stay at the same comfortable distance as the work. Your thumb on the wheel determines the feed speed. 638. If you use that pocket feeder, you can be with either left or right hands. You can reload a new wire with that one hand, and the sensitivity of the thumb wheel is good, even with a light glove on. Or start your control with the direct current straight polarity with steel as you would for steel. The high frequency starting only used unless the working on every thin piece of which causes you might have the high frequency AC instead to cover the lower heat input with the lesser tendency to burn through the thinner metal material. When using direct straight polarity, the 2% thoridated tungsten works best. The pure tungsten good at high frequency AC with the thin material. Of course, the welding rods must be stainless steel. Practice on some stainless steel scraps until you have hang of the handling of the different heat transfer capabilities. Stainless steel, your puddling rod dipping action that will be a different play pace for the middle steel. In an industry-critical weld, the stainless steel they are often made with the setup of the backside of the part of the exclude of the air with the weld, the air of the core of the shield, the gap at the top of the torch carries them and puts them on the backside of the weld can be contaminated. The pros in the back of the shield around the back of the weld are polymer and some of the extra air gun shield gas and end of the one over the other end of the tube of the carried away from the welder will purge from any of the air with the backside of the weld, which can be caused by molten stainless steel. The crystallized technique is used for protecting the back of the titanium with a TIG welding while any of the critical tubing cannot get inside the shield, and with their plug with each end of the tube, the pipe with the tape of the cardboard, fill pipe with the shield with inner air gas, particularly true with the welding stainless steel tubing meant with their carry medical ingredients or anything else that must be kept from the contamination oxidation. Although you will likely never encounter the other metals within a home shop that use the variety of special alloys, rarely used metals that have often in specialized industry that however the TIG is primarily only the only method found to do the job properly. For instance, the food service, the canning, bottling industry, there are a number of products that are transported through tubing and piping. Because besides stainless steel, nickel is often used in these applications for the resistance to alkaline acids for the same reason that is used extensively with the chemical industry. The nickel alloy pipe that used for the situation cannot tolerate with the possibility of the particular slag, such as the stick welding, MIG welding, become included with the welded bead. It would become the weakest point when faced with a continued chemical action attack as high temperatures are involved until surrounding the material is affected with the joint and weakened. For this reason, nickel work must be thoroughly cleaned before welding without using chemical cleaners or in black nickel oxide coating can form. Alright, 613 TIG welding, especially helpful in the situation with like a race car suspension upright with when you have the thin chromium moly plate tubing that you need the tube heat control. If you burn through any on the job like this, the whole part may have to be scrapped. Or 640, beautiful, precise welding welds on this race car exhaust system, particularly experienced professional TIG welding. For metals like nickel, copper, titanium, and other TIG welding has been proven in itself to be the most adaptable method, especially for the critical application. There is no flux in any kind of the TIG welding. There is no chance that even a minute slag particle being included in the weld bead. Industry is also capitalizing on the finer grain structure of the TIG welding. So it aims to heat effective the area of the nearest weld. The helium is most often used to shield the gas on the nickel for that is hotter arc, which allows the higher welding speed as the gas flows to 330 cubic feet an hour. Depending on the work thickness, the polarity is used. The set with the DC set straight polarity, except for the thin work with the high frequency AC can be used to prevent hot burn through, and the higher frequency control through the start only using operated tungsten. Filler rods must be nickel to nickel alloy. Oxidation can be kept at the minimum, keeping the filler rod at a low angle to angle of the work, keeping the rod tip at the shield gas envelope. It is not done often, but the TIG can be used to repair cast iron. Welding supply store has the specialist rods that are called cast with gray iron called 3-in-1. These should work either gas or TIG welding, although the same preheating instructions apply to the above discussed welding cast aluminum parts. Alright, the helical arc and TIG welding is likely to remain its mostly shop-only process due to the expense of the equipment, length of the learning curve, but doing a discount something you can try. If you know someone whose shop is with the TIG equipment, ask if you can spend a few hours closely observing them with a suitable spare helmet on, of course, performing TIG welds with a later splatter. The lack of splatter of the smoke with the TIG welding means that you can observe the process better than most without the welding methods. This will tell you much of you more about how the process works in the chapter works in this chapter and then a chapter in a book. If you feel that you've observed enough to get a good idea, see if you will let you try it out. But first, offer to pay any of the tungsten you ruin in your practice. You may find that you have a hidden aptitude for the hand-eye coordination. A hidden aptitude to hand-eye coordination. TIG may be a process that appeals to you. Alright, that was notes, and this is one of the last chapters, plasma cutting and welding.